Hello everyone, welcome to this learning platform. I am Dr.I.Rama, Associate Professor, PG and Research Department of Chemistry, Sita Lakshmi Ramaswamy College. In this video, we are going to discuss about Joule-Thomson effect. Before we begin today's topic, let me ask you a simple question. Have you ever used a deodorant spray or a CO2 fire extinguisher? After continuous spraying, the nozzle becomes very cold and sometimes even frost forms on it. Why does this happen? The answer lies in an important thermodynamic phenomenon called the Joule-Thomson effect. In this process, a real gas expands from high pressure to low pressure region through a porous plug or a valve under adiabatic condition, causing its temperature to change. Today, we will understand the science behind this fascinating effect and see why it is so important in refrigeration and gas liquefaction. Let me discuss the experimental setup for the Joule-Thomson experiment. The apparatus consists of well-insulated tube divided into two compartments by a porous plug made up of silk or cotton. The left-hand side contains the gas at high pressure P1 and the temperature T1. The right-hand side is maintained at a low pressure. When the valve is opened, the gas slowly passes through the porous plug from high pressure to low pressure. Since the apparatus is insulated, there is no heat exchange with the surrounding, making the process adiabatic. During the adiabatic expansion of a gas, there is a change in temperature is noted, and this effect is usually called as Joule-Thomson effect. Now, in this case, the adiabatic expansion takes place by hitting the weightless frictionless piston from a position x to x dash, and thus expansion always accompany a change in temperature. There are three variations noted. In one case, at a particular temperature, during the adiabatic expansion of a gas, no heat or no cooling effect is observed. And that particular temperature is called as inversion temperature. If the experiment is performed at a temperature above this inversion temperature, this adiabatic expansion always accompany a warming effect. If the experiment is performed below the inversion temperature, then the adiabatic expansion accompany a cooling effect. This is Joule-Thomson effect. Now, let us analyze the total work done. On the left hand side, the gas is pushed towards the porous plug. Hence, work is done on the gas, which is equal to minus P1 V1. On the right hand side, the gas expands after crossing the plug. Therefore, work is done by the gas, which is P2 V2. Total work done during the process is W, that is equal to P2 V2 minus P1 V1. Since the process is adiabatic, Q is equal to 0. Applying the first law of thermodynamics, delta E equals Q minus W. Since Q is equal to 0, delta E is equal to minus W. Substituting the work expression, E2 minus E1 is equal to P1 V1 minus P2 V2. Then E2 plus P2 V2 is equal to E1 plus P1, P1. We all know H is equal to E plus PV. On substituting that, E2 plus P2 V2 is equal to H2 and E1 plus P1 V1 is equal to H1. Then H2 is equal to H2 now. Then H2 minus H1 is equal to 0. Then delta H is equal to 0. Hence, it is proved that the Joule-Thomson expansion is called an isoenthalpic process, meaning the enthalpy remains constant. Let me move on to the application part of Joule-Thomson effect. The Joule-Thomson effect has two important applications. One is refrigeration, another one is gas liquefaction. In both the cases, the principle is same. A gas is first compressed and then cooled and finally allowed to expand through the expansion valve, which acts like a porous plug in Joule-Thomson experiment. During this expansion, the pressure decreases, and for the gas below the immersion temperature, the temperature also decreases. In a refrigerator, this cooling effect is used to absorb heat from the surroundings. In gas liquefaction, the compression, cooling, expansion cycle is repeated several times until the temperature falls below the boiling point and the gas condenses into a liquid. So, in this way, the Joule-Thomson effect is applicable to refrigeration and liquefaction. Let us summarize today's discussion. The Joule-Thomson effect is the change in temperature of a real gas when it is allowed to expand from high pressure region to low pressure region through a porous plug or expansion valve under adiabatic and isoenthalpic condition. If the gas is below its inversion temperature, it cools during the expansion. If it is above the inversion temperature, it warms up. This principle is widely used in refrigeration and gas liquefaction. Thank you for joining me today. Hope you find this video useful and easy to follow. Keep exploring, keep questioning. See you in the next video.